Hi and welcome. My name is Daniel Bogdanoff and we are streaming live from Keysight in Colorado Springs. Thank you for tuning in. We'll have some Q&A at the end of the stream, so put any test gear questions you have in chat and we will field those at the end of the video. We have Erin monitoring chat off screen and she's going to come out for that Q&A at the end, so you can type in, you're talking to Erin if you're talking in chat. Today we're drawing a bunch of winners for brand new gear, including a 200 megahertz 4-channel oscilloscope, a couple of these handheld DMMs, some passive 200 megahertz probes, BenchView software, and today's bonus giveaway, 3 of these 33622A dual output 120 megahertz true form waveform generators. These are super awesome. They can do like IQ signal generation built in. They can act as a 100 megahertz pulse generator with less than a picosecond of jitter. And you can create all sorts of fun arbitrary waveforms using the BenchView software. There's like the built-in Waveform Creator Pro built into that software. You can sign up each day for the giveaway at wavekeysight.com or use the link in the description. Each drawing includes all of your entries, so you don't have to sign up every day, but you probably should because that increases your chances of winning a prize. Each day's video has also included a daily test gear tip, and they're usually pre-recorded, but today we're going to do it live because nothing ever goes wrong with live demos. For today's tip, I want to address a super common misconception that people have when using scopes. There's a mode called AC coupling that's a mode in your channels, and a lot of well-respected engineers I've spoken with over the years, they don't always use it right. So today we're going to look at the right way to use AC coupling mode on your oscilloscope. AC coupling mode essentially puts a high-pass filter on your input, so all the DC and low frequencies get blocked out, leaving just your AC signal. This is really nice if the AC portion is only what you want to focus on. For example, a lot of people use it to look at ripple on a DC power line, and this is a great way to use AC coupling. It's useful for looking at that ripple because it allows you to zoom in vertically on the ripple, and you can then do FFTs to determine noise sources or do better ripple characterization. Without AC coupling mode, you run out of headroom. So picture a DC power line, maybe at 12 volts, and there's some ripple on top of it. If you want to zoom in on that, you're going to have to turn your scope's offset, and you crank it down and move that signal down. Eventually, you're going to run out of room. So if you turn on AC coupling, you can pull off that 12-volt offset and then really get a nice time per division, voltage per division setting on your scope. And this is what AC coupling was made for. But the trap that people fall into is they think, hey, I'm looking at AC signals. I'm just going to go ahead and turn on AC coupling. That is a bad idea, and here's why. The AC coupling filter isn't a brick wall filter. It's not all or nothing. It's kind of like the inverse of the bandwidth of your scope. AC coupling progressively attenuates the signal as the frequency gets closer to 0. And this isn't just a Keysight thing either. I've personally characterized the AC coupling modes on a number of scopes from a number of different scope makers. This is universally true. So let's look at what happens if you use it wrong. Let's pop into my close-up camera here. And if I look at, this is the scope we're giving away, by the way. I have my waveform generator hooked up to channel 1. And right now, I have a 1 volt peak-to-peak 100 hertz square wave piped into my signal. If I go into my channel 1 menu and change my coupling, right now it's in DC. This is kind of the default mode. If I go into AC coupling mode, watch what happens. My signal changes significantly. So look how the square wave got super warped just because we turned on AC coupling mode. So why is this happening? Remember that a perfect 100 hertz square wave is essentially just a 100 hertz square wave plus all of its, it's a 100 hertz sine wave plus all its odd harmonics up to infinity. What's happening on this signal is that the lower frequency parts of our square wave are getting filtered out by our AC coupling filter, and the high frequency portions are getting through, leaving us with this warped version of our actual signal. If you were checking a clock signal, for example, and saw this, you'd potentially get the wrong idea about what's actually happening on your device, which is it's not good. Another example, we'll pull up a 10 hertz sine wave. So I'm going to go back into my waveform generator mode, and I'm going to turn on a sine wave. You can see all the different waveforms this creates, and there's also an arb in there. And I'm going to change my frequency down to 10 hertz. So let me go back into DC coupling mode before I lose everything. Waveform generator, frequency, use my multi-purpose entry knob and get that up to, I'm just going to go to 10 hertz because it's a nice round number. I'm going to zoom out a little bit and make sure my trigger level is correct. So that all looks good. And then if we look at our peak-to-peak measurement, we're measuring 1 volt peak-to-peak, and this is great. that's exactly what I'd expect. But if I go into AC coupling mode, so I hit my channel menu, and I go into AC coupling mode. So remember, at 1 volt peak to peak, and AC coupling, my amplitude has dropped down to 675 or so millivolts. So if you were measuring, again, if you just went into AC coupling mode because you were looking at AC signals, you would potentially get the wrong measurements on your scope. So obviously not good. The moral of the story is don't just turn on AC coupling mode because you're measuring AC signals. Use it when you want to look at an AC signal that's riding on a DC signal. For best results, we recommend only using AC coupling for sine waves above 100 hertz and square waves above 200 hertz. Otherwise, you're just setting yourself up for trouble. There's also a blog post on this topic over at blogs.keysight.com. There's a link for that specific blog post in the description. And if you have questions about that or other topics, put them in chat. I'll be happy to take them in QA, and then Erin will come out for QA at the end also. And she's checking the chat now and sending questions over to me. If you're not watching live, you can still put questions in the comments, and we'll look at those and get back to you as soon as we can with answers. And now it's time to draw some winners. And as we pull those names, I just want to remind you, on Friday, we're also giving away a 6 gigahertz 6000X series scope, one of these bad boys. Oh, I'm going to pull it out just for fun. It's just a great scope. It runs on the same interface, same graphical user interface as like the 1000X. And actually, some of the chips are the same in these. So fun fact, if you have a 1000X, it's going to run some of the same stuff as the 6000X. It's pretty cool. So today's winners, the first winner of the 1000X scope is Beon Rogers. Congratulations, Beon. The winner of the handheld, 2 winners of the U1233A handheld multimeters go to Sean Warkentin and Faharumega Puratama. Congratulations to those winners. You'll win a nice little handheld multimeter. 2 of these probe packs. These are 200 megahertz switchable 10-to-1 probes, 10-to-1, 1-to-1 switchable probes. Those go to Logan Robinson and Nicholas Santamaria. Congratulations to those winners. The BenchView license, that's a perpetual for your whole life with all the goodies. BenchView license goes to Taylor Gibbons. Congratulations, Taylor. And then 3 of these 120 megahertz dual output function generators. I love that thing. Those go to Stefan Biringer, Arpit Verma, and Dong Il Kim. Congratulations to our winners. We'll be in touch with you in the next 72 hours. We're about to do some Q&A, but first I want to bring up another schematic challenge. We did one last week, and it was a big hit. We post those on the Keysight Bench Facebook page, and we have a couple more coming this week over on Facebook. So if you do the Facebook thing, go check those out. The schematic challenge is in 3 parts, and it's a nice little theory brush up. So here's the schematic challenge for this week. Part 1, design a passive circuit, which is a filter, using resistors and capacitors, which has a gain of 2/3 at DC and a gain of 0 at an infinite frequency. Part 2, change your design to have a gain of 1/2 at infinite frequency. And part 3, convert your design from using resistors and capacitors to using resistors and inductors. Erin, you can come out for QA. You can check your answers over on the Facebook Bench page. And if you don't do that, you're out of luck, I guess. So now that's the end of the formal live stream. It's time for some Q&A. So let's go ahead and have a seat. And we may experience a brief volume drop here because we have to make sure our mics are balanced. So let's see what some of the questions. Erin, do you want to introduce yourself?
Hi, everyone. I'm Erin. I'm a product marketing engineer here at Keysight. I've recently been working a lot with the new 1000X series, so excited to talk about that some more.
Yeah, and you've probably seen Erin on some of our other videos, and she has a new video series coming up. What is the video series title? I don't want to say it wrong.
Exposing signal integrity myths. This is all around some of the different things that you have to consider when you're looking at the signal integrity of, sorry, I just was told my mic's not working, and I'm on, so.
Okay, so we're going to share a microphone here.
Let me mute mine.
Yeah,
all right.
you're muted now.
All about,
talk about it, and I'm going to check the soundboard here.
So basically what you should be considering when you're looking at the signal integrity of an entire oscilloscope measurement system, what the important aspects are. So things like ADC bits versus ENOB, how to measure your noise floor. So make sure you look out for those videos. Those will be coming up probably towards the end of this month.
Awesome. Thank you. I think we fixed it a little bit. If it's a
Awesome.
problem, I'm going to put my mic
All right, we'll
over
be good.
here. I will say real quick, normally at the end of Scope Month or Wave every year, we do a thank you to the whole crew for everything that helps, because it's not just me and Aaron up here doing this. There's a whole team behind us. So, and our media guy got had a medically significant issue and is out. So we have a whole team of backup. Matt Campbell's running the video board. He's just learned how to do it. Boone Campbell, no relations, running the soundboard for the first time ever. So just huge shout out to that team. Boone is also the person you want to get an email from if you win. So, all right, let's look at some of these Q&A questions that popped in. Aaron, any that stood out to you during the chat?
Yeah, one of the first ones, I guess we'll start easy here. Can you tell us more about the new 1204G scopes compared to the existing 1000 series scopes? So our previous 1000 series scopes basically just didn't have all the capabilities of this oscilloscope. So this has new built-in instruments like the waveform generator, the digital voltmeter, the frequency counter, so the frequency response analyzer as well. And it also has, LAN connection. It has a lot more triggering capabilities, math capabilities. So just a lot more that you can do, much higher waveform update rate in this series.
Awesome.
Yeah.
One of the questions popped up, are the DMMs true RMS? Can we go to this close-up camera here? If you look at the top of the screen there, yep, true RMS meters. So I think all of our handhelds that we make, all the handheld DMMs, all the actual DMMs that we make are going to be true RMS. I think they all run off the same chipset. So yes, all the DMMs are true RMS. Here's a question, noise reject and high frequency reject in the trigger menu. Do you want to speak to that one, Aaron, or you want me to?
You can, yeah.
Okay, so if we pop back up to the close-up, if you go to the trigger menu, let me pop in there. There's a couple different trigger options. So there's trigger types, which we know are all the different rising edge, falling edge, that type of thing. And you can actually look through. There's a few options here. The other options, auto trigger versus normal trigger. That's if you have a really slow, if you have a slow trigger that doesn't happen very often, the scopes are essentially gonna always auto trigger. And unless you put it into normal mode, and then it's actually going to wait for a trigger. There's no timeout. Coupling, so just like the channel coupling that we talked about today, there's AC and DC coupling, and then what else is there? There's a low frequency reject, and then there's some other options there. There's a noise reject, and then what was the other question? So we'll talk about noise reject first. Noise reject, essentially, if you hold this down, I'm going to pull up the help menu and just read it. It adds hysteresis to the trigger circuitry. So essentially what's happening is the trigger circuit path, like the analog path where when the signal comes into the scope, it gets split off. And I think we talked about this earlier this week as well. It basically can do some processing on that signal and get rid of some of that noise so that you don't trigger on noise. So if you think about a sine wave, but then with a bunch of noise on it, that noise is actually going to create a bunch of edges, and the scope's going to want to try to trigger on those noise edges. So you can turn on the high frequency reject or the noise reject and make sure you're getting a cleaner trigger on that signal. So it's kind of like almost going into averaging mode or adding a hold off. Yeah, awesome. Any other questions?
Yeah, there's a whole bunch. So one person commented that it seems like the new scopes are much more of a multifunction oscilloscope, which is definitely true. It makes it really nice. There's a lot of basic functionalities of other instruments into these Infinivision oscilloscope boxes. So it makes it really nice when you're trying to do basic testing if you need to put in a low frequency waveform into your device, or if you need to quickly see what the peak-to-peak voltage is, you want to use the DVM. So it makes it a lot easier having it all in one box. And then someone else asked, are the 4 channels of the DSO 1204 sharing the same ground, or each of the channels isolated from each other? And the answer is that they're using the same ground.
Awesome. Someone asked what the best cheap bench power supply is in Keysight. I'm actually going to pull it up. We have a couple options. So we just came out with I'm going to step out of the focus here for a second. We came out, I don't know where, we had it out the other day. It's probably on the ground here somewhere. A triple output power supply. So we have this one came out maybe a year ago, and it's really heavy. So I'm just going to set it here on its side. This is a triple output power supply, and then we also have these little guys. And they come in a bunch of different power ranges, and the new ones are black. Mine's a little older. And they're just like one current voltage output rating. You can kind of pick the power spec that works best for you. So that's what we recommend for that question.
Awesome.
Yeah.
And then somebody else asked, what are the parameters that I need to be looking at when buying an oscilloscope? So definitely first and foremost is bandwidth. You have to make sure that you have enough, sorry, I keep forgetting I have to use this mic. You have to have enough bandwidth to measure all of the signals that you need to measure. So the rule of thumb is to have a bandwidth 3 times higher than your fastest sine wave and 5 times higher than your fastest clock signal. So make sure you have enough bandwidth. The other big one is channel count. You need enough channels to analyze all your signals that you need to at the same time. Sample rate is a big one. You have to be able to collect enough data to get the accuracy and the detail that you need in the signal detail. And then kind of along with that is waveform update rate as well. You have to make sure that your waveform is updating fast enough so that you are capturing all of the rare signal events that are going on.
Yeah.
Those are big ones. Yeah.
And generally on sample rate, no one's going to my knowledge, sell a scope that has too low sample rate. So bandwidth is a key spec there, but having overhead in the sample rate is a good thing. The rule of thumb on that, and I think someone asked this in a previous live stream, is with Nyquist, you can just say, hey, double the sample rate is fine of the highest frequency you're measuring. But when it comes to like putting this into reality and building it into a scope, we generally say 2.5 times is the minimum sample rate.
Yeah, 2.5 to 4 times.
2.5 to 4.
And for sample rate, another thing you need to look out with the higher bandwidth scopes that have really high sample rates, sometimes there's some ADC interleaving going on there, and sometimes that can actually mess with your sample rate a little bit and give you a distorted signal. So I have a tip coming about that in my new Exposing Signal Integrity Myths series, so make sure you look out for that when you're looking at sample rate.
Great. Someone, Mayank Patel, asked, can we hook CRO probes? Sometimes people call scopes CROs or CROs like cathode ray oscilloscope. Can we hook those directly to the AC mains? And for that region, it's 230 volts, 50 hertz. We never ever recommend that. There's a bunch of threads out there on how to do that safely. So if that's something you really want to do, then you can. But there's a huge caveat. We don't recommend it because it's really easy to shock yourself and have a bad day. So. Someone's asking out for the giveaway. You're a student. Can I participate in the sweepstakes? Yes, you can. In the company, just put self or student or whatever. That'll be no problem. Can you show us a sample of all the waveforms the generator can make? Yeah. Let me pull those power supplies out of the way, and you can start walking through those.
Okay. Oh my gosh, this one's really heavy.
They're not light. There's a teardown on the Keysight channel of these, and it has like the big toroidal transformer and all that with John Kenny. You might have seen John Kenny on the EEV blog channel a while back. So Aaron's going to walk us through the waveform generator. It should all be hooked up into channel 1.
Let's see if I can do this upside down here. So waveform generator. So we can turn that on with this button down here. And then if we go into waveform types right here, we can do sine wave, square wave, ramped, pulse, DC, noise. So that's what the 1000X series oscilloscopes are able to do. And then the higher end Infinivision scopes, like the touchscreen scopes, like the 3000T, 4000X, 6000X, those have arbitrary waveform generators in them, so you can store arbitrary waveforms as well, and they have a few more waveform generation capabilities.
Awesome. Great. And then as you get higher up, some of the other scopes, like you just said, have some other ones. I don't know if probably won't pull it up. But some of the big, like the 4000X and the 6000X also have 2 waveform generator outputs.
Yeah.
So I don't know if you said that. I'm sorry if I'm repeating
I
you.
did not say that.
So that's really super duper useful.
Yeah.
And you can do like modulation and stuff like that too. So you have these outputs, but then there's also more that you can do internally. Someone says, I accidentally logged in more than once a day during February. No, you are not disqualified. Don't worry about that. That's no problem. Let's see, what else? Someone says, EEV blog is awesome. Yes, we do like the EEV blog. I really appreciate how honest and fair he is with everything. He's also a big fan of Keysight scopes, just to say. Someone asked, where's Keysight headquarters located? So Keysight, as you know, global Keysight is located in Santa Rosa, which is about an hour north of San Francisco. It's in beautiful wine country. And then we are here in Colorado Springs. So the digital group, like back in the day, it was logic analyzers and all kinds of digital type products used to be, or they're still here. And then scopes are here also. So the new UXR that just came out was designed in-house. It's actually manufactured in this building. And if you go way back in time when this was HP, if we can pop to the close-up camera super quick, if you look at this BNC cable, this was actually probably made in-house here. You can see the HP logo on it. There used to be like wire pullers and stuff, just down the hall. So pretty big site here in Colorado Springs also. Other questions coming in? I saw you checking the data sheet.
Yeah,
What are you looking
someone
for?
had asked about the external trigger on here. On the previous, or the two-channel 1000X series models, you can view the external trigger on screen. Someone was asking if you're able to do that on this model as well. I don't think so. Daniel, maybe you can correct me if I'm wrong. The main reason that we had that showing on screen on the two-channel models so that you could still do things like three-wire SPI testing, but since you have the 4-channel capabilities, you don't really have the need to view
Right.
that as much.
So adding the third and fourth channel took away that trigger in, which essentially acted like a single
Yeah.
MSO channel.
And it does still have an external trigger on the back here. I just don't think you're able to view it on screen.
So these are built on custom ASICs, and we basically were able to kind of hack into that hardware in the back end and add that MSO channel, but we do not have that option on the 4-channel. But you have 4 channels, so you don't, like you said, you don't need the third one.
Yep.
Someone's asking about the main difference between different types of waves, like square waves and sawtooth waves. Most of them are pretty self-explanatory. It's like a sine wave is a sine wave, and a saw wave. A great resource for this is like if you look at synthesizer tutorials, like the music synths, they talk through it, and you can actually like hear the difference in those because they have different harmonic content. So there's a couple of great tutorials out there, especially if you're into music, on synthesizers and different types of waves and what they sound like and how they operate. It's also good for modulation too, because that's kind of the backbone of an old school analog synthesizer. Can someone explain why you choose a G model versus the A model?
Yeah, the very simple explanation is that the G model includes the standard waveform generator and the frequency response analyzer capability, and the A model does not. So basically, before you buy a 1000X, you just have to decide whether or not you want that capability in it.
Awesome. Someone asked about FFTs, if you want to start playing with that.
Yeah.
And show that off. Someone else asked, what is your first electronics project that made the magic smoke? For me, I was working on this was, back when blue laser diodes were super new and cool, and I was building a laser to pop balloons and stuff in my college dorm because what else are you going to do as a double E student? And I didn't get the voltage regulator right on the LED, and it was it was a $40 LED diode, which was in college. It was really sad.
Yeah.
So that was my first magic smoke project. Do you have any stories around that? Maybe college labs? No. Aaron gets everything right the first time, so
Yeah,
it's
I do.
not a problem. FFTs. There's also, Aaron did an awesome video on FFTs over in the Scopes University videos. If you search our channel for that, there's a great rundown of how to do FFT on Scopes.
Yeah.
But
Yeah, I'd say definitely head over there to get the all the details about it. But yeah, basically there's a front panel button for it here. Basically an FFT will allow you to view the frequency domain of your signal while you're on a time domain oscilloscope. So that's just able to give you some insight into some of the different things that are going on in your signal that you may not actually see in the time domain. There could be some glitches or errors that you might see the frequency peaks of in your FFT that you're not actually able to see in the time domain. And the FFT also allows you to view the harmonics of your signal as well. So yeah, I guess
Awesome.
go over and check out that video.
Yeah, go check the video out. Proyectos LED is down. Hi, how's it going? He has a pretty big channel. You should go check it out. I think it might all. I don't know if it's all in Spanish or not. If you speak Spanish, definitely go check it out. If you don't, we'll put a link or a card for that for his channel. He's saying, hey, I usually work with mains, 50 hertz. Can I use AC coupling, or is 50 hertz too low? Generally, if you're working with mains, don't use AC coupling. We recommend that you should use sine waves at 100 hertz or higher for AC coupling. The reason is you get that amplitude attenuation. And when you're working with mains and just checking it, you don't really need to filter out DC components. So it kind of goes back to that trap of don't just turn on AC coupling because you're working with AC signals. Turn it on because you're trying to pull out a big DC offset. That's really the best, and that's what it's designed for. So that's how we recommend using AC coupling. And good to see you again. What else do we have? I don't think we do group delay measurements on these scopes. No, that's more of a signal analyzer thing. What else? This scope does not have a battery backup. There are some third-party, aftermarket options that essentially you can just, it's a battery that has an AC output, like an inverter or something you can plug in. That's how we recommend going with a battery. Once you're floating your scope, there's a whole bunch of other concerns. So we have an app node. If you search for like floating your oscilloscope, there's an app node on how to do that safely. Sometimes you need an isolation transformer, and you can do that type of thing. But we design them to run off of the wall. So that's what we recommend. What else? Someone mentioned Jeroboam Fenderson. He does like the oscilloscope music thing. Essentially, they use XY mode. So instead of time on the x-axis and amplitude on the y-axis, and we'll wrap up our stream pretty soon. Essentially, instead of time on the x-axis and amplitude on the y-axis, channel 1 is x and channel 2 is y, or they're switched. And you get this kind of cool plot of the two, and you basically plot their amplitudes against each other. And if you hook it up to music, you can hear how that works. They hook up like the right channel to channel 1 and the left channel to channel 2, and then you can do all kinds of patterns and stuff with it. That's pretty cool. Yeah. It's best on an old analog oscilloscope just because of the way XY mode works. On digital scopes, XY mode is done digitally, whereas on analog scopes, there's actually like it pipes the signal right to the deflectors in the tube. So XY mode is actually arguably better on an analog scope if that's all you're using it for, but a digital scope wins in pretty much everything else. Other questions? Yeah, sample rate of the DMM. I don't know what the sample rate is off the top of my head. Data sheet, always a good place to check. Especially, it's going to vary by DMM as well. Right. Yeah. I don't know enough about DMM sampling to know how the sample rate even factors in, but
I know about these babies right here.
Okay, we'll take another question or two and then call it a day. Can you say, so what does the probe voltage, like what's the maximum input? It's going to depend on the probe you're using. There's a maximum rated input on the input channels. You can check that in the data sheet. But then as you add attenuation ratios to your probe, so a 10-to-1 attenuation ratio will essentially give you 10x the amplitude input without blowing up your scope. But always be cautious hooking up to high voltage signals and double check to make sure you're not going to zap your front end, because then you have another magic smoke story, and that's not so good. Let's see. A low current probe. Do you want to answer that one?
What was it?
Best probe for low current?
The
answer is always going to be it depends.
The model number. Sorry.
So I mean, if you're looking at like AC cut, like voltage ripple like this, we have a voltage rail probe that's really good. There's a few different.
N2820A. It's a really good high sensitivity low current probe.
Is that the one that does the dual ranges?
No, that's a different one.
That's a different one.
Yeah, that one's good too, though.
Yeah, we have a probe that does like a zoomed in view and then a zoomed out view. So if you're working on like IoT devices or something, you have small little activity going on and then it drops way out into sleep mode. You don't have that. It addresses the same challenge you actually would with AC coupling, except that you can view both modes at the same time, but then you have to use a more expensive probe.
And I was getting my probes mixed up. That is the
That is
dual
it's
channel
pretty
probe.
cool.
The
There's a video on that
M2828,
somewhere too,
yeah.
I think.
Yep.
Yeah.
Yeah, they're in the probing pitfalls playlist that we have on YouTube, or the probing playlist. You'll find
Yeah.
a video about that.
Another awesome video series that Aaron helped put together. Will It Blend? You know, back in the day, I emailed the Will It Blend guy to see if they wanted to blend a scope, but they never got back to me. So you can go spam that channel, and maybe we'll send them one. Although it is a little sad. It'd be sad to blend a scope, so maybe don't go spam them.
I might cry.
Okay, last question. Someone's asking about wireless communications. This scope has Ethernet, and most of the other scopes that we have an Ethernet. It doesn't do Wi-Fi, but you could get an Ethernet to Wi-Fi adapter, and then you're wireless. So there you go. That is all for today. Thank you so much for tuning in. Aaron, thank you for joining me on the live stream and helping with QA.
Thank you, guys.
So make sure to subscribe to the Keysight Labs YouTube channel. Check out the blogs channel. Check us out on Facebook for more schematic challenge posts. Anything else you want them to do, Aaron?
Check out my video series when it comes out.
Yeah, stay tuned. So if you're subscribed to the Keysight Labs channel, you'll see those coming out. I think they're actually mostly edited and everything, and they are fantastic. So stick around for that. They're kind of in the vein of the eNob tech tip that you had on, I don't remember what day it was, Thursday maybe? Anyway, check it out. Thanks for watching. I'm Daniel Bogdanoff, and this is Aaron, and we will see you later. Dip to black. FTB on the far right. There it is.